window, it will look something like that. So there's a couple of things that they're generally asking you for in these problems, and it's A, it's B, it's C. So this problem is asking about B. It's asking you to figure out where this top point is. But within each of these letters, there's actually two numbers that it could be. It could either be the X value or the Y value. All right, so notice how this one asks for the maximum height. It doesn't ask when the maximum height occurs. It just says what is the maximum height. So this is asking for the Y value. Okay, now do you have the ability to graph this for us in Desmos real quick?
Yep.
So I want you to graph it and then give me the Y value at this point B. You should be able to just click on it and it'll tell you that value.
Zero.
You're telling me that this maximum height is at 0.
That are 7.79791.
Okay, but we want the Y value of this ordered pair. Like I want you to graph it and then click right there at the top and tell me the Y value there. And if it's not clear what I'm asking for, I can show you it, but
Yeah, it's not showing you right.
okay. All right, so let me switch windows to where I can graph this for you so that you can see the steps here. Because really all I'm trying to train you to do is to use the tool correctly. It's like how to use the hammer. All right, so let me share this other window here. Here we go. So when you graph it, a couple of things here, you generally don't use the variables that they give you. You can use t, but it's usually better to convert it to x. So if you graphed it, you may see something like this on the right, and it's like, well, that doesn't show me anything. I can't see the top part of it. So there's a couple of things you can do. You can obviously zoom out until you see it, but it gets to be too thin. Now you could just go and click on it, okay, but you can actually change your window with this wrench over here on the right, and it's worth playing around with a little bit here. Like we only care about the 0 value on X to, we'll just say 10 seconds. And notice how it already kind of framed the graph a little bit better, so we can have a little better visual of it. So I was asking you to come up with the Y value up here. Can you confirm that you have that on your side as the
I
Y
have
value?
it.
Okay, perfect. Because that's what it's asking for in the problem. It's asking for what is the Y value there. Let me go back to the other screen. And it's all about interpreting. It's like, okay, what is the maximum height? Well, that's the Y value, because it could also ask, when does it reach the maximum height? When does it reach the max height? And that's the X value. So there's two questions in the code in there: when and then what, that you may have to distinguish between. All right, so let's look at another question here. Another one of these word problems. The graphing is really a big part of being able to be successful in this part of the course. So I would encourage you to continue to graph as much as you can. And like I said, don't worry about the equation, or don't worry about the words. Just say, okay, there's an equation right there. And they want, in this problem, they say, actually, I didn't snip in the question. They want you to figure out how long does it take the object to hit the ground. So again, it starts at some height and then it hits the ground down there. Now I know your graph goes on forever, but you really want to ignore those extra parts here. When you see that, you just want to visualize it taking this trajectory. If you're ever throwing anything off a roof or a tall, it does take the shape. Obviously, it crashes into the ground. So just like the last problem, am I asking about A, B, or C in this when it says how long does it take the object to hit the ground? Which place am I interested in?
B.
I'm sorry, B. So B is the maximum height. Like A means you're up here and you're about to throw something off a building. And the object, I mean, it takes this path where it goes and it hits the ground. So C is the ground. A you can think of as the starting point, or like the initial. And B is the maximum position. So we care about C. Okay, so could you graph this for us and then give me the coordinates of C, the ordered pair?
Mhm. Um, would it be a decimal? I mean, would it have a?
Yes, yes.
Okay. Okay, then I have it.
Okay, what's the first number?
0.
Nope. We're looking at C where it hits where it's along the x-axis.
Oh. -0.76796, comma 0.
Okay, give me that first number again. 7, what did you say?
796.
Is there a decimal somewhere?
-0.796.
No. So Jeremiah, I mean, I don't know what you're looking at. I think you're giving me the point over here. And I want the one over here to the right.
Oh. Okay, I got it now.
Okay, what is the first value?
2.46.
Okay, that's good enough for me. So the first value, X, in this problem, it's really T, and T represents time. And the second value is the height, which is in feet. It actually doesn't even say what it does say feet. Okay. So the idea is that you're at 0 feet. 0 feet means that's when you've hit the ground. So when it says how long does it take the object to hit the ground, you're looking for the X coordinate there. Now, why can't it be the negative number? Does that bother you at all that the time would be negative?
No,
So in your experience, how have you heard time be used negatively?
never.
Never. So time is always considered positive. Now you could say, well, what about the past? Well, we don't talk about it. We don't say -1 days ago. We use another word. We say yesterday, or -7 days ago. You say last week. But time, generally, you think of time as moving forward. And in your problems here, you only want the positive time.
Okay.
All right, so let's look at another question here. Something really odd is going on. Every time I try to snip the question, it's not giving me the equation. Okay, here we go. All right, again, like I really reading it is not necessary. It's very distracting, if anything, because you don't really care what the scenario is. You just care what it's asking you for here. All right, so again, like these problems all have this shape where they start at some number, they go up and they crash down. and there's three places of interest. There's like three spots where you care about. So A is the initial position, B is that maximum height, and C is when it hits the ground. When you read just this last part here, is it asking about A, B, or C?
B,
So it's asking for the max height.
A, A.
You're just guessing. Can't guess. Like the A is the initial position. A is the initial position, goes up to the max height, and then at C, it comes crashing down to the ground. So crashing down to the ground is height 0. Like you have a certain height. I don't know how tall you are, but your height is not 0. If your height was 0, you would be much closer to the ground than you currently are. Okay, so we're asking about C, like that. Okay, so could you graph this for us and give me the coordinates at C, please? The XY pair at C.
$21.739, 0.
Good. So the X coordinate in this case is this length right here. This is X. And the Y coordinate is your height. So the answer is the X coordinate because it tells you how far distance wise you've gone out horizontally. Like imagine you throw a marshmallow away from you, it will land some distance away. Did you ever do a long jump or a triple jump in school, high school, middle school?
No,
No. Okay. Have you fired a gun before?
yes,
Okay, so guns take a shape just like this. It's not up and down like this, but they do rise and then they fall if you aim the weapon up like that. So there's always a place where it reaches a max height and then it hits the ground. Now you're not hitting the ground when you're firing a weapon. You're shooting at a target off the ground generally. But it's the principle is the same whether you're throwing a marshmallow or firing a gun. They do have a parabolic motion here. All right, so try to like one of the things you can do when you're learning something new is to associate it with something you've already done, and that may be something here that you can think about because I'm sure you've unless you're the perfect marksman, sometimes you miss the target and you see it hit the dirt, or if you're firing in an outdoor range, you might see that. Okay. All right, so the next questions here, hard to answer these, but we can see if I can try to help here. Yeah, I can see where the issue is. All right, so let me grab a graph here, see if we can talk about this. All right, so they give you some sort of graph like this, and they say you have something at A, you fire something up into the air, it reaches a maximum height at B, and then it comes crashing down and hits at C. All right, so that's kind of what we've been talking about. There's 3 points of interest, A, B, and C. So what's going on at point A?
It's starting to rise.
Yeah, you're looking for something that says where it started. And here I'll just snip in the words because I don't know how else to but yeah, it is rising. And like it's hard to because like you never think of something like completely at 0 because once it's released, you see it rising, like you just said. But point A represents that it was kicked from the ground, or a spaceship was launched from the ground, or you fire something up into the air from the ground. All right, is that okay?
Yep.
So point B, you fired something up in the air, it reaches its apex. And if you've ever jumped out of a like a swing, there's this moment in time where you just sort of feel like you're sitting in air, and then you come crashing down again. But there's always that briefest of moment where you're like, okay, I've reached the max, and I come crashing down. So this always represents the vertex. Sometimes you're looking for a word that says vertex there, and that may help you to be able to answer this correctly. In terms of the one they want, I can see why this is really challenging because they give you a bunch of options here. But the vertex is kind of that key word you're looking for. You can also think of it as the max height or min height of the problem when you're looking at these. Max height. Okay, and then point C. Point C, you got this correct here. C represents when it comes crashing down. Sorry to be so negative, but I mean, it's really hard to think of any other scenario. I mean, you generally don't want to crash down, but that's what's going on.
Okay.
All right, so let's look at this other scenario. Have you ever flown a remote control vehicle or?
Yes, I have.
Okay, airplanes, possibly?
Yep.
Cool. There's really cool RC technology out there now. Just it's way better than when I was a kid. It's like it died after 10 minutes and you have to go wait 2 hours for it to charge up again. Way more powerful now too in terms of what you can do with drones and stuff. So the scenario here is for whatever reason, this thing is flying along and then it just stops working, which that's horrible situation, but it's already got some forward velocity. That's why it doesn't just crash straight down. It takes kind of a forward motion, and then it regains control, and then it comes back up again. And I don't know, maybe that's an unrealistic situation, but that's what they've got here. I mean, you see this in the movies, the person can't get a control, and they finally get control, and it comes back up again like that. So in terms of like what's going on at point A, there's really two things that's going on here. The y coordinate at point A represents where it started, like the height that it started at. So let me snip that in here. So the at A here, and the y coordinate is the following. It was starting at a height of 26 feet above the ground. You can see that graphically you're at 26 feet. That's the y value. The x coordinate of A is just the initial time that it took. Trying to see if it actually has this answer in here. Oh, it doesn't actually want the x coordinate there. Okay. So at B here, what does the 10 represent at point B? It's the y coordinate, but what does that mean in terms of the problem physically? Like what happens at B?
It gets lower.
It's lower. In fact, what's the height at B?
1.4.
That's the time. That's the time that it takes.
The height is 7. Actually, it's 10.
It's 10. Yeah. So it went down to 10. All right. So that means that there was a drop. And now it's also the vertex. Okay. And that's one of the key words you're going to be looking for when you're taking this on here. It actually has that in the answer. It says that, oh, this is the vertex. It's the y coordinate of the vertex. So the other thing though is that the x coordinate there at B Well, it's the x coordinate of the vertex. Like it has to be because it is the vertex. So whichever one represents where it's a min or a max, you're looking for the word vertex to answer that. Let me snip that in here. And you just said it occurs at 1.433 seconds. So at point C, it's regained its altitude, which is good. How long did it take to regain its altitude?
Um,
Well, that's not fair. How long? That's not quite. Let me not ask that way. The y value represents what in this scenario when you get back to that position?
the the height.
The height. Yeah, exactly. So it's the height of where you are when you've returned to the place that you were trying to get at. And what's interesting, and this, I don't know if this happens when you fly, but you tend to overcorrect. So you end up going a little bit higher than you should when you drop. You just, okay, let's get a little higher here.
Yeah.
All right, let's see what else we can look at today. Go to courses, go to Algebra 1. Assignments. That does take us through all the questions in that checkpoint. So just keep that in mind. Let's see here. So workbook 28.3 we can look at real quick here. It's just to solve with the graphing tool. This should be really straightforward for you now that we've talked a lot about how to graph. Now they use GeoGebra, and I think that's fine. I like the Desmos. You should use what you like. You should use what you think will best help you for this. And actually, this one's very similar to some of the questions that we were working on today. So let me just snip those in for us to look at. All right, here we go. Okay. Again, don't read the words. Words are distracting. Just go right to the equation. So there's my equation. And what is it asking for? It's asking for the maximum height of the object. It's got this shape. So are they asking about A, B, or C in this problem when they're asking about the maximum height that it reaches?
B.
B. Now, are they asking for the X or the Y value at B, which is the vertex, by the way?
Y.
Y. The reason is because Y is H. H is the height. Very good. So all you got to do is graph it and find that place. Have you ever done bow and arrow? I don't even know what to call it.
Archery.
Archery. Yeah, it's not shooting though. It's like you just say archery, I guess.
No, I'm not.
It's teaches patience, I believe. It's a lot more fun to have a bunch of rounds going through rather than you got to wait and aim and all that. All right, so here again, you got another equation. Don't focus too much on the words. This time it wants to know how long does it take the arrow to hit the ground. So you can visualize yourself firing an arrow like that. Are we interested in A, B, or C in this problem?
C.
C, exactly. And there's two coordinates to C, but the second one is always 0 because you hit the ground. That 0 means you hit the ground. So you just want the X coordinate in this case. So you could go and graph it and figure out that X value.
Okay.
So the thing is, it's nice is you actually know how to do all these problems. You just need to know which number to choose. And I think you have a better idea of that now with this. So let me see what else we can do. The limited time we have left here. Let's see here. I saw something about thick slides. I don't understand that. Okay. This is a previous workbook matching graphs to descriptions. Sounds like a lot like what we've been doing. All right, yeah, let me snip this in. We'll just a little more concentration on this this effort here. All right, so this is Oscar throws an object to his friend. Again, like that's great, but what you want to focus on is this equation right here. So when you graph it, it should look a lot like what's going on in this picture here. So there's three places of interest, A, B, and C. Which is the vertex of this one?
C.
C is where it hits the ground.
Oh, vertex. That would be B.
B, it's either the min or the max. It's the top or the highest point. So then by default, A represents the starting or the initial position. Like that. So what height does it start at in this problem?
0.4.
Well, it's 0,4. 0 means time 0. 4 represents the height. So the y value, so in this case, x is the time and y is the height. Okay, so now let me ask you another question here. I'm asking about B. When does it reach the maximum height? When does it reach the maximum height? Am I asking about time or the maximum height?
You're talking about time.
Time. So what time is it? Which of these two values is time?
X.
X. So 1.09 seconds. And then I could ask you, well, what is the maximum height? What is the maximum height? And that would be the y value. Okay, so final question here. We're talking about C. When does it hit the ground?
2.3, 0.
But I just want the number. You're giving me the ordered pair, which is true, but what is the time that it takes to hit the ground?
2.3 seconds.
Perfect. Yes, very good. All right. Well done today. So I'll send you the notes for this assignment here shortly. And thanks for letting me help you today. And I hope you have a great rest of your week.
You too.
Okay, bye now.
Bye.